Right now, an invisible force is protecting you, silently and constantly, without asking for attention. It wraps around the entire planet, deflecting deadly radiation from the sun and deep space. Without it, life as we know it would not exist. Most people assume this shield is permanent, stable, and unchanging. It feels like a natural guarantee. But that belief is dangerously wrong. Beneath our feet, deep inside the Earth's core, powerful flows of molten metal generate this magnetic field. And those flows are not calm or predictable. They shift, twist, and reorganize over time. Scientists have discovered something unsettling. This invisible shield has not always stayed the same. In fact, it has flipped many times before. North becomes south, and south becomes north. At first, this might sound like a simple switch, but it is anything but simple. A magnetic reversal is not a single moment. It is a slow, unstable transformation that unfolds over thousands of years. And during that time, the shield we depend on begins to weaken. Okay? So the real question is not just what it is, but what happens when that protection starts to fail. Because if this invisible force can change, then everything we take for granted may not be as secure as it seems. The sky above us could behave differently, and the environment around us could become far more hostile than we expect. This is not science fiction. It is a real process written into the history of our planet. And if it has happened before, then it can happen again. The only reason we do not notice it is because these changes unfold slowly, far beyond a single human lifetime. But that does not make them harmless. In fact, it may make them more dangerous than imagined. If a magnetic reversal begins, it does not happen in a single dramatic moment. There is no instant switch where north suddenly becomes south. Instead, the process unfolds slowly, almost invisibly at first, stretching across thousands of years. Deep within Earth's core, the flow of molten iron starts to lose its stable pattern. The magnetic field weakens, fractures, and begins to behave unpredictably. At its strongest, this field acts like a powerful shield, extending far into space and deflecting charged particles from the sun. But during a reversal, that protection can drop to a fraction of its normal strength. Imagine the difference between a solid wall and a thinning barrier full of gaps. Radiation that was once pushed away can now slip through more easily. As the field weakens, the magnetic poles begin to wander. They drift away from their usual positions, sometimes splitting into multiple temporary poles scattered across the planet. Compasses would no longer point reliably north. Navigation systems that depend on magnetic stability could become confused or fail entirely. Above the atmosphere, satellites would face increasing exposure to high-energy particles. Electronics could malfunction. Communication systems might experience disruptions. On the ground, power grids could become vulnerable to geomagnetic storms, causing blackouts that ripple across entire regions. But the changes would not all be invisible. The sky itself could transform. Auroras, usually confined to polar regions, might spread across much of the globe. Curtains of light could appear in places that have never seen them before, glowing in colors that feel both beautiful and unsettling. This would not be a sudden apocalypse, but a prolonged period of instability. A world where the invisible rules we depend on begin to shift. And as the magnetic shield continues to weaken and reorganize, the question becomes harder to ignore. If our planet's protection can falter like this, what does that mean for everything built on top of it? With all this chaos unfolding, it is easy to imagine a catastrophic ending, a collapsing magnetic field, rising radiation, failing technology. It sounds like the perfect recipe for extinction. But the truth is far more complex, and in some ways, more unsettling, because Earth has already gone through this many times before, and life did not disappear. Geological records show that magnetic reversals have occurred hundreds of times over millions of years. During those events, there is no clear evidence of mass extinctions directly caused by the flip itself. Life adapted. Oceans continued to move, ecosystems shifted, and species survived. The planet, in its vast resilience, carried on as if nothing extraordinary had happened. But here is where the contrast becomes impossible to ignore. Ancient life was not dependent on satellites, global communication, or fragile electrical systems. It did not rely on a network of technology that stretches across the entire planet. We do, and that changes everything. A weakened magnetic field would expose modern civilization to risks it has never truly faced. Increased radiation could damage satellites, disrupt GPS systems, and interfere with global communications. Power grids could experience repeated failures under the pressure of geomagnetic storms. Air travel, navigation, and even basic infrastructure might become unreliable. Humanity would likely survive, but not without consequences. The systems that define our modern world could be pushed to their limits. What once felt permanent could suddenly feel fragile. In the end, the real story is not about the Earth failing, it is about us. Because while the planet has endured these changes before, we have never experienced one at this level of technological dependence. The magnetic field will flip again. That is not a question of if, but when. And when it does, the true test will not be whether Earth can survive. It will be whether we are prepared to live in a world where the invisible shield we trusted is no longer the same.